Hi guys, I just thought I'd introduce this little section of 35 videos with a short intro. So, intro. Basically what we're doing, we're going to do basic differentiation. So we've got y, dy dx. And this is the table we're going to use. So we're going to rely on these, just three things. K differentiates constants, differentiate to 0. X on its own would differentiate to, say, 1, say, and x to the n. Differentiates to n, x to the n minus 1. There you go. This is all this section is going to deal with, is looking at different derivatives like that, from very elementary ones really to start with. But then we're going to look at examples like this, x minus 2, 1 plus x. We'll work out how we can use that to differentiate this. Or for example, y equals, let's have a look here, x squared minus 7x plus 4 over x cubed. We're not going to use any flashy rules of differentiation because we'll develop them in subsequent problems. But we're just going to stick to the basic principles. And how do we write that in an easy, simple form so that we can apply these and invoke these rules? So we're going to need rules for indices, for example. So this rule we're going to be using. And every time I write down and use something, I'll always put the rule down. And also we're going to use this rule. Times you add, yeah, a plus b, so that rule is also going to be used, of course, throughout. And then you've got divide you minus, so x to the a, x to the b. Divide you minus top to bottom, so x to the a minus b. So this is just an overview, a little summary of all the formulas we're going to use. And then we're going to use expansion of brackets, so for example a times b plus c. In that case you draw two lines. And you can write AB for the first lines here, and then AC for the second. So we're going to invoke that one. And we're also going to use A plus B, C plus D. And then you draw four lines for that one, two for the first, two for the second. 1, 2, 3, 4. And you end up with AC is the first line, yeah. Then you've got AD, see the second line, and the third line BC. And then the last line BD. So I just wanted to put down all the formulas, or virtually most of them, we're going to need as we go through. Each question I will hark back to these formulas and always write them down so that you're completely happy with what we're doing. Also x to the power 0, anything to the power 0 is 1, so we'll need that as well. So there's our little tool bag, more or less. I don't think there's hardly anything else that we're going to use. And we're going to use these things to do 35 simple differential problems, and these won't get much more difficult than this sort of thing here. Okay, speak to you later. Cheers.